highly
I'm sorry, I'm not able to hear anything. Just give me a moment. So can everyone hear me? Because I was not able to hear anyone. Just let me know if my voice is clear.
Yes, sir. And here, sir. It audible. Audible, sir.
Okay, fine. Thank you very much. I was not able to hear, so I thought, fine. We'll just continue the session. Um, Let me just share my screen. So we just start off a wonderful journey with NI Rio platform. Okay, where Rio is going to be used as an embedded system. Okay, on possibly on top of the Rio platform, on top of the robot, or it could be a control system, or it could be a headless system, or it could be anything. Okay, so it's going to be a system for absolutely anything which is going to run headlessly. Okay, basically a robot or anything. Okay. So in that case, we should be able to program them in such a way that it should be acting headless. So for that reason only, we were saying, okay, that MyRio was one of the tools, and I had some arguments as to why it is so. Okay, the first reason is it is capable of connecting to internet. Okay, so it is kind of capable of connecting to, basically it could connect to Wi-Fi. Okay, and that's one of the reasons why it could be used as a headless system. So whatever process needs to be happening, okay, it can happen inside the Rio, and data transfer can happen to anywhere. Okay, basically, okay, anywhere over the world. Okay, so it helps. That means it is capable of doing IoT. Okay, so this could be an IoT device on top of absolutely any type of appliance, right? So at least for prototyping purpose. So once you are done with the prototyping, people can basically remove this plastic. Okay, internally it will be only board. Okay, like PCB, right? So this is fully programmable by using LabVIEW. Everything can be programmed using LabVIEW. Okay, so that's why we just start off with our main code. Okay, that is uh, we just start off with a main program here. Okay, so where we saw that how easy it was to get the accelerometer value and possibly use it for lighting up the LED based on the accelerometer values. Okay, so I just had to do that. But let's say if you don't want to do whatever is already available, you can basically delete off whatever is available here, okay, as an option. So now like your code is clear. Okay, it's not like used for any purpose, right? So to program embedded system, okay, you're going to use only LabVIEW. Okay, so right now, previously there was a program which monitors the accelerometer data. Okay, but let's say you don't want an accelerometer data. You want something from, let's say, an outside sensors from which you need to collect data. Okay, so for that reason, what we had to do is we had to connect sensor externally and get that data inside a lab environment. Okay, it could be any type of sensor, to be honest. Okay, like for example, here I have this joystick. Okay, in front of me, do I have a joystick? Okay, so I'm not sure. Okay, you are not able to see it. Maybe I'll just okay. So I have a joystick. Okay, here on joystick on top of the Rio. Okay, joystick is basically a sensor. Okay, it is going to measure the position. Okay, I can move left, up, down, top, left. Okay, it can read anything, absolutely anything. Okay, so to read this data, I need to make use of some sort of IOs, right? I need to make use of IOs. So how do we proceed? Instead of using the default data available, how do I make use of something which is external? Okay, so that's the place where we have to go. Okay, we have to make use of some sort of IOs in our tell sheet. Okay, so first what we need to do is we need to make the connection. Here's some appropriate connections to make these readings. Okay, here I have this connector. Okay, to this connector, I'm just going to connect a 5-pin connector separately. Okay, you can see it here, right? So then later on, I have power supply ground, okay, 5 volts ground, and this is basically internally there's a potential meter inside. That potential meter data only we have to read. Okay, so now people might wonder why we need to do for this for robotics. Okay, basically to control the robot, we need to have some sort of joystick, right? So if you want to design from scratch, okay, joystick also needs to be included. So in that case, we need to check the position of the joystick, okay, and get it inside the lab view. Okay, so we have like, I'm not going to take much. Okay, I'm just going to take one channel of the joystick. Okay, only x-axis. Okay, or y-axis maybe. Okay, or both. Okay, it's not going to hurt. So I'm going to connect it to the MSP part of the Rio. Okay, so let me just make the connection. Okay, so ground goes to ground.
Sir, your screen is not very well visible.
What do you mean, ma'am?
Actually, I am seeing a very small portion of your screen actually. Your screen is a part of my screen, a very small portion.
This one, ma'am. I mean, you can
This
you
is
can
very small. Yeah.
try to attempt to double click on in your screen, so maybe it will come
Yes, yes.
exactly. So right now I'm
Now what you are showing, sir?
which one? Ma'am?
What is there on your screen right now?
Um, the one which I started last class, like this is the embedded system which can be programmed by using LabVIEW. That one. So robotics is okay for simulation purpose. Next, we need to implement. So that reason we are going for implementation purpose. We have this Rio hardware, okay, which is going to be used for prototyping. So that part we have come up.
That has become only one small square in my screen. I don't know what settings I have to make.
Okay, Google Meet, you just have to double click and it's going to open.
Pardon?
You have to double click on it and it should be a full screen for you, I believe.
No, it is not becoming full screen. I
Okay,
think
maybe if I stop sharing my
sorry,
screen,
sorry to other participants.
right now you're seeing the full screen now?
Uh, no, sir. Actually, I don't know what settings I have to make. I'm so sorry for all the other
Yeah, it's fine,
participants.
it's fine, it's totally fine.
Yes, sir. You can carry on, sir. I will try something.
Yeah, sure, thank you.
Yes. If init is coming, sir. If init the screen is coming.
Okay, so since I'll go back and forth between my screen software and that, I'm not sure, but I think if you click on that, okay, maybe you should be able to. I mean, don't click on my screen. That is this one. You should be seeing this. So I believe, I'm not sure. Probably you can just Google the solution. Probably it will come up.
Okay, okay, sir. Okay, no problem. Please carry on.
Yeah. Okay, so I'll just have to make the connection. Okay, so here I have this ground. Okay, so my area is basically, it's similar to DAP. Okay, you have to just give the connection. Okay, so here you have this ground. So the ground, I have this kind of the ground wire. Okay, ground, I'll connect ground. And there's like 5 volts here. Okay, for which I need to connect the 5 volts. And for y-axis, I'll connect to analog ground, I mean analog input. So yesterday we stopped my DAC, right? So same thing can be done in my DAC also.
Sir, I'm getting one message here. I can read: to avoid mirroring, don't share your entire screen or browser window. Share just a tab or a different window instead.
Okay, so possibly if I stop my presentation of my screen, because I can go back and forth. Now
Now I
you're
can see the full screen, sir.
okay, so I'll go back and forth, not a problem.
Okay, sir.
Okay, so right now you're just seeing the connection part. After I done the connection part, I'll show my screen.
Thank you.
Okay, so first power supply and ground. Okay, then here I have this analog input 0, okay, to which I'm connecting the y-axis portion. Okay, then I have to, this is differential connection. Yesterday, I think my colleague would have explained about what is differential connection. So I hope you have not missed the class. Okay, basically like an oscilloscope, if you want to make the connections, you need to have 2 wires, okay, to measure potential difference across some resistor components or some components. Okay, so basically floating point values, if you want to make measurements, you have to make use of differential measurements. Yesterday, I think they would have told you in detail. Okay, so one point of measurement only I'm going to make. Okay, so here only one value is coming outside. I'm not going to make any differential measurements. Rather, I'm going to make with respect to ground. So A is 0 plus, I'm connecting to the signal source, sensor source. The second pin that is minus needs to be grounded. Okay, if I want to make an appropriate measurement. So ground is available here. Okay, I believe proper connection has been made. Okay. So basically, when this is in center, okay, I believe nothing has come outside. Every connection is whatever I want to make inside, it's inside. Okay, of course, I won't make connections of switch and the x-axis thing. Okay, so the other connections are intact. Okay, so what I intend to do is when I make some say measurement, some orientation change, okay, that should be reflected onto your lab view. Okay, so let's come back to this is connection. Let me just check in my lab view screen. I'll stop sharing my screen here. Okay, I'll switch off the camera. Now I'll come to screen sharing because now connection is done. We have to go for, you know, this thing. Then next I have to be looking at lab view screen because I want to make measurements in lab view. Basically, when this joystick as a center, okay, I don't make any change, okay, it will be showing 2.5 volts. Okay, when it goes up, it will become 5 volts. When it goes below, it becomes 0 volts. So 0 to 5 volts, it will be in the center when we don't make any change. So depending on where you're going to up or down, it's going to have different measurements. So not to make these measurements and bring it in lab view, we already made the connections hardware wise. Software wise, what you need to do is you need to, use Myria's function, that is unlock input. A sensor data needs to be brought inside, so they're going to use unlock input. And what is going to basically happen is here you have to, maybe you can say if you want, okay, you can say joystick reading. It says joystick reading. Then you have to say which channel. Okay, we have connected the joystick to AI 0 plus of port C. Okay, this is port C. Okay, the one which I connected was port C. Port A and port B was other side. Okay, we have 3 ports basically. Okay, if you saw the your PPT, okay, we have this MSP connector which looks similar to MyDAC. This is called as port C. Okay, port A and port B on the other side. Okay, this side. Okay, Myri has two sides. Okay, the second side has more input and output. Okay, but if you want something similar to MyDAC, you have on the other side. So if I want to access this 0 plus and 0 minus, I need to select here port C A0. And here I have to mention as Y axis. I mean, when I said I have to, okay, I don't really need to do it. Okay, but if I do it, it has some good documentation. Okay, everyone can understand why we are using this function. Okay, so here it says joystick reading and y-axis, which is connected to CA0. Now let me just create an indicator to see what output it gives. By using a loop, I'll read this data continuously. I will include some timing function in order to slow down my program. And run this. It's going to ask me to save it. I'll save it. I should be reading 2.5. Yeah, somewhere like 2.5. If I make some changes, okay, so this is y-axis. Okay, y-axis data. Okay, if it is in center, it's going to be exactly at center. Okay, so I can't show both at the same time, but basically what I did was I'll stop presenting, I'll switch on my camera. Okay, you can see here that I just made this direction. Just move from left to right. Okay, that's all I did. Okay, I switch off my camera, then come back here. And now you should be able to see my screen. Okay, so this is basically analog reading. Okay, analog reading, it's going to read from any sensor, which is going to be adhering to plus or minus 10 volts. Okay, your MyRio also has a data sheet. Okay, so you can just go to Google and Google it. Okay, it's going to come up. Okay, everything has, uh, you know, specifications. Okay, so right now we're just only using 5 volts limitations, so it's not a problem. Okay, but once you go to industry, some relays and all will switch on 28 volts. So this particular hardware will not be able to sustain that much voltage. Okay, it can barely sustain 15 volts. Okay, 10 volts is the maximum measurement it can make. So it's better to make use of plus or minus 10 volt compatible. No, sensors for this particular thing. If you want to go for that, okay, basically my area is only for student use, okay, for academic purpose. You can do two things if you want to go for something higher. Either create a signal conditioning circuit here to interface with the high power circuits, or you have something called, for industry purpose, we have industrial Rio or C Rio, we call it as compact Rio. That will be, proper for high level acquisition and generation. Okay, it can measure up to, depending on the card we're talking about, you can also measure power measurements also, like to 300 volts RMS, 800 volts RMS also you can measure. Okay, maybe to do, let's say you want to measure from electrical machine, okay, voltage and current. Okay, not only can you read the RMS value, you can read the waveform information data also. Okay, up to that you can go. Right? So that's why we have this kind of programming. Right? So this is for acquisition. Okay, so let's say you want to control a motor, okay, how it's going to rotate, left side or right side. Okay, you can make use of this joystick. Then what about control of a motor? Okay, so controlling of motor, basically you can make use of by using either a PWM generator or, for robotic purpose. Let's say if say a motor is going to be, robot is going to be a autonomous vehicle, okay, four-wheeled robot. Okay, so in that case, you need to have four, motors. Okay, you want to control both the direction and speed of the motor. Okay, in that case, we already spoke that this particular Rio has a PWM generator and also has combination of DIOs. Okay, using this, you can basically control, you cannot directly control a motor. Okay, but you can have an intermediate driver just going to drive the motor. Okay, so right now with me, I have this motor and driver combo. Okay, not a very big motor I have. Okay, so if you see my, I'll just stop sharing again. I'll enable the camera. Okay, you should be able to see right now. Okay, a small motor driver. Okay, I'm sure you must have already come across this type of motor drivers. Okay, it's very prevalent across in student communities. I mean, not research. Okay, researchers again use directly variable frequency drives. Okay, I'm sure you must be aware of that. Okay, but let's say if you want the student to do it, okay, so it's better to go for something low voltage. Okay, in that case, you have this motor driver available. Okay, very famous L2 and M3D. Okay, which if you want to control, okay, you can make use of it. Okay, so I'll just make action. Um, so I'll have something like this. Okay, so for this motor driver also I have to give power supply. Okay, basically I have to give plus and minus. Okay, so I have to take two wires again. Okay, which is available with me here readily. So let me take, yes, here. Okay. Okay, I have taken two wires. One is to be connected across 5 volts and ground. So this 5 volt. I need to give for both the 5 volt power supply and this one. The other one would get. Hopefully it doesn't come. Okay, it comes outside. So wire junctions are to be given properly. So I tighten it up. Here also first I loosen it and tighten it up. Okay, both positive and negative has been connected. Okay, I believe it's connected in the proper direction. Okay, fine. So power supply for the motor is connected. Okay, now I have to connect the logic level. So three logic levels are going to be done. Okay, one is for you know the motor driving. Okay, that is whether you want to drive in the positive direction or negative direction. Okay, I'm going to use two um, logic level stuff. Okay, I'll tighten it up. Then this is for reverse. Okay, if this is true, this will be reverse. So I'll wire it to 1. And there's been a pin called enable. Enable, I'll just, for now, I'll just wire it to 3. Yeah, now I need to wire the motor. Okay, motor is over here, small motor only. So the small motor, I wire it to the motor driver. So since I'm making use of port B, I'll wire it to port B. This L293 is capable of driving true motors. So I will make the connection. Fine. Now this is as far as connection goes. Okay, I have the motor, I have the wires. I can also remove this part of the circuit because it no longer concerns us. Right? So this is what the connection is. Now basically L293D is going to receive, per motor is going to receive 3 signals. Okay, one is for forward, reverse, now one is for forward, reverse, and enable and disable. Okay, there's going to be master switch, okay, which is going to be controlling the other two. Okay, then after that, it's going to have like forward and reverse. Okay, this enable could either be used as a master switch, or I can supply the PWM signal in order to control the speed. So let's try it out. Okay, now I'll just switch off the mode camera and I'll again share my screen. Okay, so I share my screen and I go to program. Okay, this particular program was for previous code. I'll delete it. I will basically going to have another loop, and the loop is basically while loop. It's going to continuously monitor the status of any code I put inside, and the code which I'm going to put inside is basically going to be DO. Okay, I'm going to control the motor. Okay, so to control the motor, I told that this driver is going to get 3 signals, digital signals, on or off. So on or off means I need to go for something like Rio. In Rio, I have something called digital out. Okay, digital in means basically I can read data from outside. Digital out means I can write data outside. Again, here pin matters. Okay, this is port C only again. And port C, I have to read DIO0 or DIO0. Okay, not know where the connection needs to be made. I can actually go to connection diagram to see where exactly I'm going to make the connection. Okay, they are saying this one needs to be connected. With respect to ground, I have to make connection. Okay, they have said what is driving it is also they are saying. Okay, you can add a strong resistor to DIO to make it flow in the opposite direction, they are saying. Okay, so everything is documented, well documented. Here I can mention like motor drive, and here I can mention like forward, and I can add more channels as well. Okay, just by clicking plus, it's going to add 1 channel extra, and it's automatically going to add the next channel. With this I can make it as close. And for now, I'll just add one more, and I'll say it's not 2. Okay, I'll say 3, and I'll still say again, I'll say enable. I'll give OK. This will write the program for us. So I need to have appropriate buttons. I'll name this as forward, reverse. I'll have ones which says, master enable. And I don't want this to be, memory processor intensive. So I'll add some wait function inside. And this is going to be like forward is going to be the first pin. Reverse is going to be the second pin. And master enable is going to be the 0, 1, 3. Let me verify once again. Input B1 is connected to DIO0. Okay, input B2 is connected to DIO1. and enable is connected to DAO3. There is a strong reason why I connected to DAO3. Okay, I'll explain it to you. Okay, now okay, the motor is running. Okay, how I can say motor is running is basically by, how can I show? Okay, I was showing the camera, but by placing something on top of the motor so that it's going to rotate. Yeah, so right now I just need to show both of them parallelly. Okay, so I'll stop presenting and I will switch on the camera. Okay, so I have this here, and when I press forward, it's going to rotate in one direction. Okay, when I press reverse, it's going to rotate in the other direction. Okay, so I believe you can see it now well. Okay, so this type of control I'm doing it using LabVIEW. Okay, if I disable the master enable and switch on anything, okay, it's not going to happen. Right? So, yeah, I will stop the camera and come back here, present the screen, share. And now if you see in my screen, I have this master enable. Only if I switch it on and switch on this forward, my camera is my motor is rotating. If I reverse it, it's going to reverse it in reverse direction. Okay. So this type of control of motors can also be done using LabVIEW and Rio. Lab is the one which is going to control the Rio and bring data inside. Okay. So yeah. But now people might ask, sir, okay, fine. What is the difference between this type of hardware and the last one? Okay, the one reason is this could be dumb standalone. Okay, whatever we have done until now, okay, it could be a standalone program. Okay, meaning you can program your Rio and upload the code inside it so that every time you switch on and switch off and switch on, the same code is going to run again. There's something which is not possible in DAC. Okay, DAC is good for as an extension for your hardware, your computer. But Rio can do much more. Okay, so that's the one difference. Apart from that, this can connect to internet. Okay, internally you can develop a control system. You can develop, and also more than that, it has several, several of protocol based buses are available. Okay, there are if you have most of the times in many embedded system. Okay, nobody goes for EIOs or DIOs. Okay, there'll be a protocol based sensor. Okay, which will have like UART or I2C or SPI. Okay, internally inside your cell phones. Okay, there'll be SPI bus or I2C bus which is running inside. Okay, to communicate with your processor. Okay, all the information is required. Okay, mostly SPI or I2C. Okay, so internally to your cell phone, right? So that type of information, if you want to do, okay, you have to go for Rio. with a protocol-based sensor, okay, in a few minutes, right? So right now, we have seen that we are able to control forward and reverse of the motor, but we are not able to control the speed. Okay, using this master enable and disable, we can only able to switch on or switch off the main supply. But what if I want to control the speed of the motor? Okay, because in a robot, it's very important that we should be able to control it. Okay, so to do that, what we'll do is I will disable the port C in this particular program. I'll put this minus, and what I'll do is my program will compile, and this switch is only for forward and reverse. For speed, however, I'll use the same IRIO, but rather I have something called PWM generator. This PWM generator is there are, I mean, we spoke about that we have like 8 PWM generators, okay, inside MyRio. One of which is connected to port C PWM0. Okay, in port C, where it is, we can see that it's in the connection diagram. And in the connection diagram, it is specified as it's in pin number 14. Okay, so I thought it will be okay, fine. Let's check it out. Okay, so I connected in 1, 2, okay. So last one is pin number 20, right? So 20, 19, 18, 17, 16, 15, 14. Okay, this is DIO3 is only pin number 14. Okay, they could have just told PW, DIO3. Okay, so not a problem. We have found out that for pin number 14 is where I connected enable. So the speed at which this is going to switch is what is going to control my speed of my motor. Okay, and internally, we are not going to write very complex code like this. Okay, because this type of code is something called express code. It is actually built to make the job of beginning lab program easier. But as program becomes complex, you have to start writing codes like this. Okay, now here only configuration. I have to select what is going to do. Okay, it's going to do speed control. Okay, it's DIO3. We have mentioned it here. Good. Then whether I have to do speed control or the duty cycle control. Okay, I can set the speed as frequency as constant, like let's say 500 hertz for now. Okay, this is DC motor only. It doesn't matter how many frequency you keep. Okay, duty cycle, however, I set it using some input here. It's going to vary from 0 to 1. 0 means 0%, 1 means 100%. So I can either set as constant or I can give as input. If I set using input using express, it will be as an input. So this will generate the code for me. And once done, I can create a front panel of my DC speed motor control. It is not only going to control the forward and reverse, but also speed. It will vary from 0 to 1. I can mention this as speed. Now I'll run this again. Okay, so here if you see, I can vary the speed. At lower duty cycle is barely going to rotate. Okay, but as the duty cycle increases, the speed is also going to increase. Okay, so now to show this in the camera, I have to stop the presenting turn on the camera, and in my hand I have this motor. Okay, for which I'll run the code, and forward is set as forward. I'll change this frequency. It can run slowly also at lower duty cycle. Okay, but as the duty cycle increases, it will become more faster. Okay, I can even change the direction. Okay, so this much you can do. Okay, so yeah, so if you have any questions, please let me know. If you have any questions, you can let me know, or else we can proceed for the next. Okay, in that case, right now we have seen that it's also easy to control a motor. Okay, so you can control motors, you can control get sensor data from the sensors. Okay, so its job is easier done. Okay, now we have to see what is the difference, what are the advantages, more advantages you have with respect to hardware, with respect to MIDIO, apart from MIDAC. Okay, because then people will come in, then it will be like you can use MIDAC only. Why do you need to go for MIDIO? Apart from FPGAs, you have like other things, right? So apart from that, I also, like I told, okay, it has capable to read protocol sensors. Okay, so in front of me, I have a protocol-based sensor. It's an ultrasonic sensor, okay, which can read up to 200 meters. Okay, so this sensor also has an analog input. Okay, it also has analog input, but the one thing which is going to be useful is it has a TX and RX. Okay, it has a TX and RX which can be read. Okay, so let me just give the connection. Before that, I'll get another ultrasonic sensor. This seems to be faulty. Okay, I got another one. So yeah, so basically, first we need to understand that in order to make protocol connections, this side cannot be used. Reason, this side is an emulation of your MIDAC. Okay, and yesterday when they spoke about MIDAC, they told that MIDAC is not only, I mean, so it can have acquire and generate states. That's what it can do. Okay, so protocol is also signal only, but it's a communication more importantly. Okay, that hardware is not really capable of communication. Okay, if you want to perform communication, you have to go for the MXP port. Okay, in the MXP port, if you see very clearly, we have like SPI, okay, I2C we have, okay, and we also have something called UART. Okay, we have UART one channel in this. Okay, this is only one channel, one port. Okay, so two ports are same. Okay, so if you have UART here, here also you'll have UART. Okay, so I have here with me. I mean, I have to go this side. Okay, before that, I'll just disconnect the motor. I don't really need it anymore. Okay, I have my radio. And port B of my area is this side. This comes inverted, so you have to be careful. Now, if you see, we have to connect UART TX and RX to this particular sensors RX and TX. Okay, it has analog input and output as well. But if you use analog input and output, we need to calculate how to convert that voltage to a distance. Okay, but this has an intelligence. This circuit, this particular hardware has an intelligence inside. Okay, it is already calculating whatever voltage it is into a distance, and it just directly gives you what is the distance. Okay, but it sends in terms of UART. Okay, UART in the sense it's a communication protocol. Okay, basically RS-232. It just sends the data in the form of string. Okay, and you have to read it. Okay, so let us try it out. I will take the connector from the previous version. Okay, not and I have to take connectors. So how many connectors do I require? So I need two for power supply. Okay, so one is I'll be having VCC and ground. Okay, and I'll have TX and RX. Okay, basically, if you see the data sheet, okay, let me show you the data sheet. Okay, quickly open it. Okay, it's opening. I will open as soon as I get the. Okay, I got it. So let me just share my screen. So they say that serial data format is 9600 baud rate. Okay, and 8 bits parity, 8 data bits is coming. Okay, and no parity. So with one stop bit, that is all and all not required. Okay, but they are saying this is how the data comes out. Okay, so we have 5 pins. Okay, out of which 6 pins in fact, out of which one is for PWM and other one is for analog input, analog output. Okay, but instead of to avoid analog output only, we are taking UART based sensor. Okay, so connection diagram is not here. Okay, so that's why we are going to make the connection diagram. Okay, so let me take 4 wires. I have VCC, I have ground, I have TX and RX. Okay, let me just stop the presentation, switch on the camera, and here we go. Okay, I have this VCC ground. Okay, I have VCC and ground here. Okay, and TX and RS. So VCC I'll give to 5 volts. Okay, now I need to know where the 5 volts is. Okay, for that reason only we have this lab view. Okay, in lab view we can basically see where the connection is, or I can go to PPT and here I can see. Okay, 5 volts is in pin number 1. So I connect 5 volts to pin number 1. A ground to pin number 6. So these wires are very loose. Okay, you need to be very careful. Okay, if you pull it out, it's going to come out. Or else these wires must be new, so that even if you pull it out, it's going to be taking it harder to come out. Okay, so power supply is important. Once power supply is done, we'll be having 3x and TX and RX. And TX and RX basically is on both. Okay, you have TX and RX at MIDI also, TX and RX in your sensor also. Okay, so both are there. So basically, if you want to connect TX RX from a sensor to TX RX to your IDEO, you have to basically follow this switching. Okay, so TX of the sensor should be connected to RX of the Rio, and RX of the Rio should be connected to TX of the sensor. Okay, so basically transmit and receive. Okay, it's going to act like a modem. Okay, so let's try that. I have TX in my hand, RX in my hand. I have to connect to TX. And RX is here. TX is pin number 14. So this is pin number 6, 8, 8, 10, 12, 14. And okay, that is RX. RX is connected to TX. Okay, pin number 14. 12, 10. Okay, pin number 10 is TX here. TX is connected to MyRio's RX. Okay, RX is 10. I believe the connection is solid. Now what? Now that the connection is made, you have to program your computer or your MyRio to acquire data from the sensor. So I'll go ahead and delete the existing program. Okay, I will switch off my camera. Then yeah, I have to go to Rio again, programming, where I don't use the generic analog input or analog output, digital output, because those are inbuilt functions. Okay, these are to access analog input or analog output, digital output, just like that. But what do we really need is we need a protocol-based function that is UART. This particular sensor acquires and generates data in UART. So what we do is we request some 16-bit data, and that 16-bit data will be given to us. Okay, so I'll just give read. Okay, and from where is the question? So this particular has two ports, UART ports. Okay, so I have connected to port B basically. And the other things I don't really need to configure. I'll just give OK. And here I have to basically say 16 characters. Read. I'll run this loop. I'll put a wait function of, like 100 milliseconds. And I'll read it. And this program, it's going to read data like this. Okay, R007. Okay, so it's keep on shuffling. So I need to make some changes in order for it to not shuffle. So I'll change it to control. Change to control. Instead of 16, let me just keep 14. Okay, so 20 characters, possibly. I stop it and run again. It should be even if you wrote 4 also, it should come, I believe. No, 4 doesn't work. So it's going to cycle. If 5 characters is proper. So it says 7. Okay, let's stop it and run again. Keep saying 7. Yeah, actually, it should keep on changing, but maybe something has gone wrong. Okay, it's just basically reading the internet part. Yeah, so now it's reading properly. So it has to be as tight as possible. Okay, if I close my hands, it will read only 10 or something. Okay, if I remove, it's going to not read. Okay, stop and run again. So it's reading. So it has to be as tight as possible. Cannot read proper data. Yeah. So we'll be reading the centimeter data directly. Okay, now what we'll do is we have to convert this data to something which we can understand. Okay, so this is in terms of string. Now I have to remove that first character and convert into number. So if you read as a voltage, the advantage in analog input is
Excuse me, sir. Excuse
yes.
me, sir. Sir, screen
Okay.
is not visible.
Okay, I'll share my screen. So thanks for the reminder. If you see, this is what I did. Okay, so basically I removed the analog input analog function and I replaced it with, in Mario, we have protocol based functions. Okay, UART. And here I have to set the appropriate UART. Maybe it could be ultrasonic data. Okay, so I can set anything. But here I have made connections. If you saw the video, okay, I made connections on the right hand side, okay, or left hand side, or whatever it is. Okay, in the perspective of my area, it's left hand side. So I have to select as B. And the B, I have to specify by default will be read, right? Okay, I have to specify read. Okay, I have to read some data. Okay, how much data I have to mention. So I'm reading 5 characters and read a string. So when I do that, I'm going to get the data directly from my string. Okay, so first character alone, it will be like R. Okay, so after that, it's going to be, the value of distance between the sensor and the distance between the sensor and, the obstacle. Okay, but in order for this to work properly, you have to have your connections connected well. Okay, there are loose connections, it will say something different. Okay, right now, if you see, it came outside. Power supply 5 volts. Okay, so it's able to read it properly. Yeah, now it's fine. Okay, I'll stop this and run again. Now I need to remove this R alone. Okay, typically this R will not come, but I'm not sure what is the problem. Fine. Now we have to extract this R alone. To extract this R, what I will do is I will remove that R, okay, by using a function called as search and replace string. Okay, I'll input this string. I'll search for R and replace it with an empty. So it has been replaced. Okay. So search and replace string, remove the R. Okay. So after that, if you want to remove something like empty arrays, okay, empty values, okay, there's something called trim white space. Okay, so this will also trim out any white spaces in front, in between. Okay, is this going to give me a plain value? Any caps would have been removed. Then this is in terms of, string. I just need to make use of a function called as number to string conversion. Okay, I'll make use of this string to decimal. And now I'll get in terms of number. That's it. Right? So the same reading, but now in terms of number. Okay. So the one advantage here is this is okay. Okay. But let's say if you're trying to read some huge amount of data. Okay. So one particular hardware has huge number of input and outputs. Okay. So in that case, we need to use an appropriate, protocol to read the data. We cannot really make use of, AIO and DIO. Okay. If you want to read, like hundreds of analog input data. Okay. And there will be some standard instruments in the industry, okay, which will convert this data to, the probable data type. Okay. So if you want to directly read from those type of instruments, okay, we will be going for some protocol. Right. So then such protocol is this something called as UART. Okay, I'm sure you will be familiar with. Okay, there's nothing but serial communication. Okay, apart from that, we have SPA, I2C, everything is available. Okay, it's totally up to you. If it is not available, then you can, go for analog input or analog output. But that's again depending on the type of sensor you're going to use. Right. So these are the features inside the lab view. Okay, and normally in order to do this RS-232, you need to have a computer which has RS-232 port. Okay, nowadays no computers come with the RS-232. Okay, if you want to do that, you need to have an embedded system which has this RS-232 port, which all these microcontrollers and microprocessors still have. Okay, to read the data, again you need to program it. Okay, and that programming normally as RS-232 programming, serial programming is not really easy in other programming tools. Okay, of course, nowadays a lot of programming tools have come up with easier way of programming, and Lab is one such tool. Okay, where you don't do any explicit programming, you just configure the way you access the code. Just say, okay, I need 9600 baud rate. You just specify the baud rate. How many bits you specify? It's done. Any parity is there, you have to specify the parity. What is top bit? You have to tell So it will be already configured for you. Okay, you don't need to write a separate line of code to set the baud rate. You don't need to set bits. No, you don't need to do. Okay, at least the basic level. If you want that much level of flexibility, then you have to go for something called as without programming. Okay, instead of this high level, easy to program, okay, we also have something else. Okay, but now, yeah, the reason why we went for this is so many of the sensors, like for example, when we work with robotics toolkit. Okay, so in the Sense Act, we went with IO sim most of the time because we did simulator. Okay, but let's say we are going to go for an actual circuit, okay, actual hardware. In this case, any hardware you take, it's going to have a protocol. Okay, for example, if you take initial measurement unit, there are different types of initial measurement unit. Okay, out of which, let's say if I take crossbow. Okay, to initialize this, we have to give a serial port. Okay, Visa resource name. This is nothing but similar to this resource name only. Okay, channel name. Okay, so if you made the connection and you click here, okay, it's going to ask you whether it's ASRL instrument or ASRL2 instrument. Okay, so here you made a scene. ASRL2 instrument. So if you connected the instrument, this that hardware of crossbow navigation, okay, to that particular port of TX and RX, you should be able to freely communicate with it. Okay, you can configure the baud rate. By default, it will be 9600. Okay, but if you configure it, okay, you should be able to read the data as well. Okay, fetch the data from that and later convert it to whatever you feel is better. Okay. So protocol sensors are very good at getting multiple data. Okay, and most of the protocols in place sensor will be highly configurable. So all those data are easily readable by using Rio. Okay. Now everything is okay. We are able to read analog input. We will be able to generate analog output also, to be honest. Then we will also be able to do digital input and digital output. And we are also able to do PWM generation also. So it's a full complete package for control and measurements. Okay, but what makes it truly headless? Right now, if I switch off and switch on this Mario, whatever program was running will be erased. Okay, meaning it doesn't hold any data, hold any program. This works similar to your MyLab. How can you make your Mario to, you know, upload programs and better yet, should be able to control your cell phone also. From your cell phone also, you should be able to control it. How is it really possible? Okay, to answer the question, let us get into the lab view again. So I'm done with this protocol based sensor. So I'll remove it. Okay. So now, in order to see how we can make a program standalone, let me create a program which is going to help me make my Rio standalone. Okay. So in order to make my Rio standalone, what I'll do is I'll write a program which will make it appear like the Rio is standalone. Standalone means I should not be able to access my Rio in front panel or block diagram. The moment I switch off and switch on, that code should start running. That's what makes it truly headless. That's what makes it an embedded system. Right? If I not do that, what I'll do is I'll make use of only this user input, user LEDs. Okay, we already saw that your Mario has user LEDs. Okay, which I can make use of. So what I'll do is I'll make use of this push button, which when I press, this LEDs will glow. Okay, something like that. So to continuously monitor the status of this button, I will create a control. Okay, I'll create a control. And my Rio. I'll pin it because I'm going to keep two functions. Okay, one is LED. And after placing it, I'll switch on all four LEDs. Okay, I'm not going to switch off anything. All four LEDs are going to be done. Now, what I'm trying to prove here is your MIDI is not like Rio where your MIDI is not like your MIDAC where if you switch off and switch on, okay, the same sequence is not going to be there. There's no absolute connection between your computer and your Rio. Okay, the only thing is to program only you have to use a host computer. Okay, but you can dump code inside your Rio so that it's every time you switch off and switch on, it's the same code is going to run. To do that, I'm going to go GUI-less. Okay, I'm going to make use of user onboard LED, onboard devices like button and LED. So this particular function is going to read the button status. And it's going to return true or false. And using this, I'm going to say LED 0 and LED 2 should be switched on when the button is off. Okay, when the button is off, LED 1 and LED 3 also should be switched off. When the button is switched on, it should go reverse. Okay, when it's on, this will become true. Okay, when I press it, okay, 0 and 2 will be switched off and the other one will be on. Something like that. I don't want to overwhelm this IC inside. I'll add some small delay. Save it. And when I run my program, you can see that I don't have anything in the front panel. Okay, most of the Rio program internally should not have any controls or indicators. Okay, because you should not be able to see front panel only. The reason is your MyRio does not have a display. If you want to see, you need to have it wired to your, what do we call it as, your USB cable. Okay, so this is good. Okay, I'm able to see my data in my, my Rio. Okay, after I close it, I will stop sharing the screen. And what I'll do is I will switch on my camera. You should be able to see my Rio, the LEDs. Now in my LEDs, if you see it's off, okay, one of them are, these two pairs are off. Now what I can do is I can press my button. Okay, so I have programmed in such a way that depending on the button state, different pair of LEDs is going to switch on. So you can see the same happening. When I press the button here, okay, it's going to alternate between these two buttons, these two LEDs, like this, right? So this type of programming can be done. But now the thing here is what I'm trying to explain is this will not exist when I switch off. Okay, if you see, I can switch off my Rio by just switching off my power supply to it. And when I switch off, okay, my computer also, my connection to my computer also has stopped. Okay, if I turn off the camera and present my screen, in lab view, it says that connection to the target has been lost. Okay, even though it looks like your computer is connected to Rio and your computer is only controlling your Rio, as a matter of fact, your code went inside your Rio and is executing there. You are only able to see the status. Okay, but if I switch off and switch on my Rio, the code will no longer exist. Okay, so I'll switch on it again. and Rio is again connected. Okay, switching on. So how do I say it's switching on is basically it's like a computer only. After it switches on, only a connection will be made. Okay, once the connection is made, it will get connected. Now, if you see my camera, none of the LEDs are glowing because when you switched off the camera, okay, the whole program went to halt. So now, how do I make it in such a way that every time I switch off or switch on my computer, I switch on and switch off my power supply, it should run the same program. To do that, we have to change something in your program, okay, in your lab view. Not exactly in the program, not exactly in lab view. In the way you compile the program is what is existing. So I want to fix this as your code. Okay, I want to fix this as my code, right? So what I'll do is I will save this. I'll save this. Okay, this code is saved. This is what is going to be put inside my Rio. It's going to be put inside my Rio. Okay, so what I'll do is I'll close this off after I save it. Okay, but in order to store my program inside my Rio, what I'll do is I will right click on build specifications. Okay, it's all in the way of how I compile. Okay, basically when I switch off and switch on, my program should start running. It's basically an application. Okay, since your MyRio has an operating system, it is having a programs running inside. In that case, whatever program you want to deploy inside your Rio, it should be an application. It should be an exe file. Okay, it will not be exe file. It will be a file called as rt.exe. Okay, rt.exe. Okay, basically it's real-time operating system. So whatever program you deploy as a executable will start running immediately. So to do that, you have to right-click on this build specification. Okay, under MyRio, you have to go to new real-time application. Okay. So it says my real-time application, startup.exe, it doesn't matter. What does matter is you have to go to source time. Okay, so whatever code you have written, if you want to deploy inside your Rio, okay, are we able to see the screen? Okay, I think we are able to see the screen. Yeah. So if it needs to be deployed into your Rio, as like when you switch off, it's the same code should run, you have to include a startup Rio. Then give OK. So now what you can do is you can build this code. Okay, it will compile and it will get deployed. Okay, so once it's done, I'll just click done. Now everything is not done. Okay, I have to deploy the code inside my Rio. So what I'll do is I will set this as startup. Okay, I'll right click on this and set this as startup. Then I have a button called deploy. which when I press on it, it will start deploying my application. Okay, inside my Rio, this whole code will be dumped inside, and whenever I switch off and switch on, that code will start running. Okay, it says deploy successfully. And when it's deployed successfully, you have to again run a startup. Okay, your system will reboot. Okay, the way how we can see reboot is I have to switch on my camera, switch off my presentation, and you can see that my system has switched off. Okay, so it will reboot. You can see the status LED. It will go for a while, which means it's switching on. So it's switching on. So OS is booting inside. It will take some time. Okay, once it is done, it will start running the code which is inside. You will see these LEDs will go. Even though it's RT's real-time application, it will take some time to start up because internally we have something running inside. Okay, so once it's done, it will start running. See now, you can see that this LED start to glow. I can press the button to toggle between two pairs. And this happened immediately after I switch off and switch on. So this is how we can dump code inside Rio. Okay, even if you switch off again and switch on again, the same code should start running. So it will take some time to reboot. So this makes it a very good, way to deploy code inside your Rio. Okay, and it's very useful for robotics because in robotic applications, your card will not be, your computer will not be always tethered to your computer. Okay, it should run standalone. Your robot should be purely, um, self-acting. And when I say self-acting, it will not automatically start to think. Okay, that part we haven't gone yet. Okay, but still we can code intelligence inside it. Okay, so based on the conditions of the sensor, something needs to happen. So like that, you can start coding. Okay. Apart from that, if you want to, let's say, communicate with the hardware in standalone, we need to make use of some network protocols. Okay, maybe some using IoT we can communicate, or using Wi-Fi we can make local area network to make the communication. Okay, so that we will see now. Okay, so right now we are able to see that your program is running automatically. Okay, whenever you switch off and switch on. Right. Now the thing is, how do we control it when the program is running standalone? Okay, if you see, my program will not be able to interact with it. Okay, so it will be like the program is not running at all. Okay, because the program is now running inside your Rio directly. There is no communication between your computer and my Rio. And if I run the program now, it will say that something is already running inside. Okay, I will switch on the camera, press the screen again. It will now say that the target is already running a real-time startup application. If I press OK, it will abort the application which is running inside. I'll run the program just here. So if I run this, if I say OK, whatever program was running inside will be overwritten. It will be overwritten. And I press stop. Okay, it will stop. Okay, you could see here that whenever I stop the program, still that LED is glowing. Okay, basically what you need to do is you need to reset the Rio. Okay, every time it stops. So reset will reset all the IOs. So when I stop it, my Rio IOs will be reset. Now let's say instead of this particular, way of controlling by using the button which is available on my computer. Okay, I mean on top of the Rio itself, I have this LED. I have this button which is controlling it. How can I communicate with my Rio using my computer, using my cell phone? Okay, there is a way for that as well. Okay, because for Rio to for to communicate with the robot, we cannot always expect us to be connected to PC. Okay, if you want to, check out the data with respect to the Rio. Okay, let's say you want to immediately do it. You don't have access to computer, so you should be immediately able to get data from your by connecting it to the Wi-Fi. You should be able to get it. So how do you do that? So instead of getting this button value from here, what I will do is I will create something called shared variable. So basically, now you might ask what exactly the shared variable is. So the shared variable is nothing to be afraid of. Okay, so shared variable is like a variable which can communicate between two different targets. Okay, on the two different targets of NI product. So right now I have LabVIEW in my computer and LabVIEW in my Rio. So that's why they are communicating properly. Okay, if not, then it will become a subject of, if not, you need to use something like very generic protocol like TCP/IP, UDP, or something like that. Okay, so if you want to communicate with my cell phone needs to have a product, okay, which is NI verifiable, and we don't have LabVIEW for cell phone, but we do have something called data dashboard by Lab NI. Okay, NI is provided something similar to LabVIEW. It is not programmable. Okay, it is not. It does not have block diagram. It has only front panel elements. Okay, so that can be communicating with your Rio. So we're going to do just that. Okay, using this variable, I will be able to pass data from my computer, my cell phone, to my Rio. So I'll create this variable. Okay, I'll say switch for this LEDs. So when I say switch, it's going to be a Boolean. Okay, so if you see there is a two symbol of globe, meaning it's going to be connected together. Okay, I'll save this library and deploy it as data. Okay. Now, in order to communicate within multiple targets, what I'll do is I'll just drag the switch and place it here. And basically from network, I should be able to get this data of switch. So instead of from the IO of my Rio, because we don't know where the Rio will be. Maybe this Rio could be on on a ground level, okay, on top of a robot, which is accessible, or this Rio could be on top of a drone. Okay, if it's on top of the drone, it will be on it will be on the air. Will not be able to communicate. So to control the drone, we need to be able to send data wirelessly. Okay, so for that reason, we need to have some network communications like this, which makes it possible. So once I made the connection, okay, I will say like deploy. I'll open the DI. I'll run the code. Okay, now my LEDs cannot be triggerable. Okay, because I'm not able to pass any data. Okay, because it's reading from the variable. Okay, so if I switch off, it will switch off. Okay, but before running again, I'll just deploy this variable. I'll say deploy all. It will be deployed across all the targets. Okay, I can again run this program. And now to control it, what I'll do is I will have my cell phone. Okay, I'll see if I can show a screen of my cell phone. Okay, I have something called AnyDesk. Okay, I have AnyDesk. With this, I can make the connection. Okay, so I just made the connection from my 626860570 cell phone. And I just made the connection to my Rio. And I already told that my Rio is connected to Wi-Fi. Okay, so I cannot do that basically because when I switch to Wi-Fi, internet will go on. Okay, so not a problem. I'll show it in the camera. Okay, once I've done configuring it. Okay, I'm just configuring my mobile app to get data. Okay, I'll use a control switch. Okay, I have to enter the appropriate IP address. IP address is different for Wi-Fi and IP address is different for yeah, made the connection. Now I cannot show it here, but if you see in the screen, I am able to communicate with Rio. Okay, how I can do that is I can switch off the stop presentation. I can turn on the camera. Okay, I'm not touching anything in my Rio. Okay, I'm just switching off and switching on. Okay, between two states. Okay, how it happens is basically simple. Now I have a controllable dashboard in my cell phone. So I have to switch here. Okay, which one I press, okay, it will communicate with my Rio. Okay, I cannot show both of them because probably now I can show. Okay, whenever I press this, okay, it's going to alternate. Right? So this happens because my cell phone is connected via the Wi-Fi. Okay, once it's connected, I can make use of in the inside Rio have initialized communication protocol, okay, called a shared variable, which is exclusive to LabVIEW. It will help me communicate with my cell phone to my computer, to my Rio. And inside the Rio, we are taking the data from the communication and we are controlling the LEDs. So this could not be only LEDs. Okay, it could be basically to control motor. It could be control anything. Okay, with respect to robotics or control system or anything. Okay, so these are the capabilities of my Rio. Okay, with which with your imagination, with your ideas, okay, you can implement whatever part of implementation you want to implement for robotics. Okay, if it's only for simulation, the first half of for today's program is sufficient. But why stop with simulation when you can go ahead with something more? So simulation is only for validating a design. Once your design is validated, you need to be able to implement it. That's what completes the part of your application. So if you have any questions, you can ask right now. Or else I'll turn off my camera. And any questions are welcome. Or else I would like to conclude the session. Yeah, very good. Okay. Contact number. Yeah, surely I can share. I'll share my screen right now. So in the last section of my PPT, okay, I have my contact details. So if don't have any questions, I do have my contact information. Okay, if you have any other specific questions or any queries, please do contact me. I'll also copy paste this in the comment section. If it's useful, please do take use of it. If you have any questions, please let me know. In that case, thank you everyone for this attending this session of mine. Okay, and the pre sessions. Okay, that is the LabVIEW as a tool for simulation. Okay, you start day 1, day 2, and not only LabVIEW did you learn. Okay, we had to learn multisim as well. So all of this combined together probably could be used for something much more larger. okay, by you, or it is being currently used as well. That's the entire thing. But how effectively you learn and you have implement it is what is going to make impact for you, right? So if you have any questions, you can ask, or else we can conclude this session. So thank you very much for giving me this opportunity for presenting my experience on how you can make use of LabVIEW for electric, for robotics simulation. So it's been a wonderful journey, I believe. So I have already shared my screen, my contact information. If you have any questions, you can ask, or else we can conclude the session. I would like to, give the control over to coordinator, sir.
So, any questions from participant side? So, thank you, Mr. Rajkumar ji. It was very nice to hear you, and we learned lots of things regarding simulation of robotics using LabVIEW, and also some basic concept which was not clear to us. But now we are we got the all the clearance, and doubts are now clear. So thank you, Rajkumar ji, and it was very beneficial for all the participants. So on the behalf of organizing committee, I would like to thank you again. And dear participants, now this is the end of the fourth day. Tomorrow at 10 o'clock, we will start the last day of our FDP. And tomorrow also we will conduct a quiz uh, based on the all the lectures covered by here. So kindly prepare for this. It will be 15 to 20 questions objective type. So kindly prepare for it, and also we will do for the feedback. But this feedback is from our side, but you have to also do the feedback at the ATAL portal, which is mandatory for getting the certificate. Three things is mandatory. First one is attendance, second one is your performance in quiz, and third one is feedback. So three things are mandatory. So it is advisable to, after end of the FDP, kindly logging into the ATAL portal, and uh, fill the feedback form on ATAL portal. And rest two things we will do, the your attendance and your performance in quiz, we will upload it. Then after that you are able to get the certificate on ATAL portal. So any queries or suggestions, kindly mail us or WhatsApp me. Okay. So thank you, Rajkumar ji, and all of you. So this is the tomorrow at 10 o'clock we will meet. Thank you.